subject of discussion is Knorr-Pyrazole synthesis, or a method of synthesis given for the pyrazole by Knorr. That's why it is named after him as Knorr-Pyrazole synthesis. It is an organic reaction in which an hydrogen or its derivative reacts with 1,3 dicarbonyl compound to give substituted pyrazole ring system in the presence of acid as a catalyst. This was first reported by Knorr in the year 1883. That's why it has been named after him. Here, the hydrogen or its derivative or NHNH2 reacts with 1,3 dicarbonyl compound in the presence of acid as catalyst to give two types of pyrazoles. Okay. Let us look at the reaction mechanism, how the reaction occurs. First, the acid H3O plus reacts with 1,3 dicarbonyl compound. The pi electrons in the carbonyl carbon moves towards oxygen, and this combines with H plus and protonation of the oxygen takes place and lead the release of water. I have got protonated dicarbonyl compound. First step is the protonation of the carbonyl carbon. As the pi electrons are moved to form towards oxygen to form the protonation of the oxygen, it renders this carbon electron deficient. That we have represented as a positive center. As this is the positive center, the hydrogen or its derivatives can react to this. The amino group of the hydrogen has lone pair of electrons, and as this, because of this lone pair of electrons, is electron rich and this is electron deficient. As we know, unlike poles attract each other, when I supply heat energy, the lone pair of electrons forms bond with the carbon, which is electron deficient, and it has to maintain its tetravalency. That's why OH gets kicked off. This H plus and OH minus, they combine together to lose as water molecule, and it gives rise to an imine. As this are shared with this NH, this is still positive, and to satisfy the positive center, this electrons moves and imine is formed. The hydrogen derivative here reacts with this protonated carbonyl carbon to yield an imine. The reaction do not stop over here, as there is a carbonyl carbon which is electron deficient and another amino group which is electron rich, and they are near to each other. The lone pair of electrons forms the bond with the carbonyl carbon, and the pi electrons moves towards the oxygen, and O minus, it combines with H plus and it gives rise to OH, and the cyclization occurs. It undergoes dehydration. This H plus and OH minus, they combine together to lose as water molecule, and I have got pyrazole molecule. I have synthesized the pyrazole. The cyclized compound undergo dehydration and it gives rise to pyrazole. This is given by Knorr, and hence it is named after him as Knorr-Pyrazole synthesis. Next class we can deal with the synthesis of another heterocyclic ring system.